So the next speaker is Stefan Krickl he's student at the TU München, or I think graduate now. He recreated the ENTSO-E Bidding Zone review with PyPSA and played around with some different data there. So Stefan, the floor is yours.
Perfect. So currently in Europe, we are reviewing our bidding zones. This is based on nodal results. And in my thesis, I worked with the clustering, and therefore I'm going to present you my talk with PyPSA meets the BZR data. And I'm currently waiting for my grade of the master thesis. So I had the problem I was lacking data for my thesis because I just wanted to look at the clustering, and the PCR results come without any geolocation, which makes it quite hard to cluster and without any topological information. So back in autumn 2024, me and my supervisor and advisor looked at it, and the solution was for that. Let's just recreate it for Germany with PyPSA. So why recreate and why PyPSA? It is reproducible. The latest study talking about it is Knör et al. 2025. They did it in R scripts, but there are no open source reproducible nodal pricing models yet that use the BZR data. More on that in the conclusion in the end. Why PyPSA? So I needed marginal prices for each buses in order to cluster them. It's scalable for large networks, and the PCR dataset is really, really extensive. There was an active community and development going on that's just attractive when you start new with a tool. And also, I'm sure we will hear about it later. The Open 10-year network development plan that is coming up with PyPSA and the talks that were already there with ENTSO-E. So initially, I had the idea to first import to PandaPower because PandaPower has an existing import for the data format. More on that on the next slide, and then convert it to PyPSA. During this conversion to PyPSA, some problems arose with rewinding transformers and switches. Therefore, I decided, okay, I need to do it myself and do a deeper dive. Therefore, a quick overview over the data that is provided with the bidding zone review. There are two kinds. We have the public data and we have the non-public data. Public are the results and the input data. The results contains information about the cleared demand, generation, the nodal prices, the constraints, the resulting welfare, and for the input we get the generational data and load data for the climate years and the study year. The study year for the bidding zone review is 2025. The input data is a bit more complicated than this simple sentence, but a little bit this later. Non-public is the network grid model. In order to obtain it, you need to sign an NDA with ENTSO-E, and it's provided to you in the format CGMES. This is hierarchical structured data model, and just as an overview, the lowest level is the terminal, the highest level is the geographical region. The terminal represents the connection of an electrical component to the topological node, and the topological node can be understood as a bus, which is the essential building block of any model with PyPSA. So I started building up my buses, took the voltage level, had my nominal voltage. At a certain point, I wanted to add the geographical information. Looking around in the data that is provided, I figured out there's no geographical location provided within it, except for 6 sub-geographical regions. Those are the 4 regions of the TSOs we have in Germany, and the Baltic Sea and the North Sea. So my solution for that as a student was first kindly ask ENTSO-E for a bit more data, and then I got back they can't on security grounds. So knowing that it is possible to recreate it and find geographical locations, I then dove even deeper into the data and started reading in detail and found out some of the substations have human readable names. Some of those human readable names match with locations that you can find on Google Maps, OpenStreetMap, or the OpenInfraMap, and you are provided the exact line length between the substations. So using open source data, and I'm sure all of you are way more familiar with that and way more practiced with them than I am. I was able to code a bit and do a bit of manual search and work, and was able to localize 34 substations. Using the localizations, I then could continue to build the topology, resulting in the graph I have on the right side here. The blue lines are the AC lines in the model. The green lines are the DC lines that go across the whole country. Each of them has a capacity of 2 gigawatts. And to fill out the topology, I then had to add the switchgear. Those are just lossless links. I also modeled the high voltage DC lines as lossless links in order to make it a bit easier. And also, I was missing more exact data on them in the model. And adding the compensators, the final part was connecting the different voltage levels. For the free winding transformers, I used a similar method that Panda Power is using, converting them to two winding transformers. And this resulted in the topology you can see on the right-hand side. I continued with the loads. The loads were quite straightforward. You can now see the larger the circle, the higher the demand is. In total, the peak active power demand for just Germany in the BZR data model is 76.2 gigawatts. Not so straightforward were the generators. Here, I had a bit of trouble assigning the thermal generators to their exact type because ENTSO-E differentiates between the age of the generator, not only the fuel type. I had to summarize those into just the fuel types: lignite, gas, head coal, and other conventionals. And then more straightforward was adding the renewables, biomass, non-biogenic waste, offshore and onshore wind, and hydro run of the river power plants. Within the model, there are no storage capacities for Germany when you look at it isolated. And the keen eye might already have seen you clearly see the split between South and North Germany. In the north, you have the larger wind energy. In the south, you have the solar potential. And one might also wonder why is the wind onshore, why is wind offshore capacity plotted on onshore? This is because there are duplications in the data. And ENTSO-E models the offshore wind parks twice, once at the location where they are really located, and once on the location where the high voltage DC connection connects to the AC grid. For my purpose, I then just used the locations on land because I did not have time to add real weather data. And concluding, I can say I used the model for obtaining the nodal prices and was able to solve 155 days out of the 168 days that are under consideration in the bidding zone review. We have 3 climate years. For each climate years, there are 8 weeks. And the model made it possible in a quick afternoon of coding to use for the entire year 2024. For that, I simply use the data that is provided on the transparency platform of ENTSO-E. And this was quite contrary to the main report that was published in April 2025, where ENTSO-E acknowledged that their input data is outdated. And my experience was I had an easier time importing the data from the transparency platform than the input data that was provided with the bidding zone review. The lack of transparency and documentation of certain design decisions made it quite hard to follow along with the ENTSO-E, and I had to include quite a few assumptions at certain points in the modeling process. And what I conclude a bit and what I want to give you or talk or give you to think about is critical data is publicly available in the internet. And I think we should rethink the approach of sharing data with researchers, because currently it involves a lot of rebuilding and not continuing on the work that has already been done. With that, I thank you for your attention and I'm open for your questions. For longer follow-up questions, please contact me via the forum.